Okay, so today in class we practiced some pretty complex chain rule problems. What I'm going to do right now is go over some of the problems that you guys may have done in class, and hopefully by going through them step by step it'll clarify any of the original errors or questions that you had, and also help you see that there are some procedural patterns that we follow when we're trying to simplify these types of expressions. So the first problem that I'm going to go over, the original function is y equals parentheses, and then on the inside, negative 2x squared minus 3 cubed minus 2, and then squared. Right away that I can see this is a chain rule problem, and the reason I can see that this is a chain rule problem is because I have a function nested inside of another function. So if I rewrite this in colors, which is what we kind of did for a couple days just to practice seeing this, we're going to have the outside function, which is the squared, and then we're going to have the inside function. Now the first layer of inside function is something cubed minus 2. And the final layer of inside function would be the negative 2x squared minus 3. So I'm going to have 3 layers of my chain rule here. Now, when I want to find the derivative, I'm going to do those one layer at a time. So I'm going to start with the purple layer. I'm going to drop the 2, leave the inside alone, change the power to a 1. Now I'm going to leave all of this stuff that was inside there the same as it was. It's not changing. Now I need to deal with the red layer. For the red layer, I'm going to look at this cubed. I'm going to drop the 3, leave the inside alone, and change it to a squared. And the derivative of negative 2 is 0. So that would be the end of the red layer. And last but not least, I'm going to do the green layer, which would be negative 4x. Now this is one big product. I'm taking layer by layer by layer, and I'm multiplying their derivatives together. So in the end, I can do some simplifying that will make this look a little bit nicer. First, I'm going to look for any coefficients. 2 and 3 and negative 4x can all kind of get pulled out to the front like a coefficient. So I would get negative 24x. And the rest of the problem is just going to get copied down exactly as I see it. So parentheses, parentheses, negative 2x squared minus 3 cubed minus 2. And then this part right here, so negative 2x squared minus 3 squared. Now I did have some students asking me, why don't we distribute? Why don't we go any further? Because of this cubed and because of this squared, if I wanted to go further, I would have to write this function out 3 different times and then FOIL all 3 of those together. I would need to write this one out 2 different times and then FOIL all of that together. That's just way too much to not really get any simpler. So in the end, this is my final answer. Now that's a pretty basic one. I think most people who tried number 1 towards the beginning of the period were feeling pretty good. Let's look at a problem that gets a little bit more complex. This was problem number 3 from class today. So I'm going to have y equals parentheses negative 2x plus 3 parentheses negative 4x squared minus 3 squared. Now right away I can see that this is a product of 2 functions. I've got this first function here, and I've got the second function here. In order to take the derivative, I'm going to need to use product rule. But I notice that as part of this function, the red one, I've got an outside and I've got an inside. So we usually call that nested chain rule, meaning it's chain rule as one step of a bigger rule, the product rule. So the way the product rule works, we would say we copy the first function, which would be negative 2x plus 3. We take the derivative of the second one. I'm going to do this part in red. To take the derivative of this guy, I need to do it in layers. So I would drop the 2, leave the inside alone, which would be negative 4x squared minus 3. Now the new power here is a 1. I don't normally write the 1. And then I take the derivative of the inside, which is negative 8x. And that is all part of the first step of product rule. Copy the first, derivative of the second. Now I'm going to put a plus sign because product rule says we add. And I'm going to copy the second, which would be negative 4x squared minus 3 squared. Derivative of the first, which would be negative 2. From here, it's just a matter of algebraing, which I do understand is actually, for the most part, the harder part. What I'm going to do is I'm going to basically simplify all of this stuff as much as I can. I'm going to simplify all of this stuff as much as I can, and then I'm going to look at it as a big picture. So to simplify this stuff, I'm going to look for the 2 and the negative 8x to become coefficients. So I get negative 16x, and then I'm going to copy everything else down, times negative 2x plus 3 times negative 4x squared minus 3. Then again, I'm looking for something I can simplify, so I'm going to make the negative 2 a coefficient, and I'm going to copy down the negative 4x squared minus 3 squared. Now I've got basically two separate terms here. All of this stuff is one term, and all of this stuff is another term. Some students were asking me, couldn't you just FOIL all of this out, distribute the negative 16x? Couldn't you just distribute the negative 2? The reason you can't just distribute the negative 2 is because of this squared. The squared means that in order to simplify this, I would need to write this twice and then just FOIL it all out like I would do for here. To avoid having to do that, because that's a lot of steps, I'm going to look for a common factor. So I notice right away that both of these terms are divisible by negative 2 because negative 2 goes into negative 16. And there's a negative 2 in the second term. I also notice right away that this term, the first one, has one copy of negative 4x squared minus 3, and this term has 2 copies. So the most I can take out is 1 copy, and then let's look at what's left. Now I took out a negative 2, so this becomes a positive 8x. This negative 2x plus 3 doesn't change, but I took this one out here so that I don't have to write that anymore. I took out a negative 2, so I'm going to make this a plus 1. I took out 1 copy of this guy, so I would make that a negative 4x squared minus 3, and not squared, just to the first power. And my last thing I'm going to do is simplify what's inside of here. So if I distribute this, I get negative 16x squared plus 24x. If I distribute the 1, I just get negative 4x squared minus 3. And then I'm just going to bring down the other ones. So I'm just going to bring down the negative 2 and the negative 4x squared minus 3. Now basically by factoring this out, I avoided having to FOIL anything. It was a pretty straightforward distributing problem. And now I'm going to look for like terms that I can combine. So the negative 2 parentheses negative 4x squared minus 3 doesn't change. This term and this term would be like terms. So I have negative 20x squared, and then I'm just going to copy down the plus 24x and the minus 3. And this would be my final answer. So this problem got a little bit more complex than the first one because instead of just having a big chain rule problem, we actually had a long kind of nested chain rule problem. The next one is going to get a little bit more complicated again. So what we're doing in this one is problem number 6 from what you guys did in class. The original problem was that y is equal to negative 4x plus 3 over parentheses negative 5x to the 4th plus 1 squared. Now what I see right away here is that I'm going to need quotient rule. I can also tell that as part of quotient rule, when I do low D high and high D low, to do the derivative of the bottom, I'm going to have a nested chain rule problem. It's going to need chain rule to just do the derivative of the bottom. So let's get this show on the road. Here we go. Low, which would be this guy, D high. So the derivative of the top would be negative 4. Now I'm going to put a minus and I'm going to do high, which is negative 4x plus 3, D low. Now this is where we have our nested chain rule. To do the derivative of this part, I'm going to drop the 2, leave the inside alone. I could write that this is to the first power. I don't usually do that. And then derivative of the inside, which would be negative 20x to the 3rd. And then low squared goes down below. From here, again, it's just really a simplifying game. So I'm going to look at this first term and see if I can rewrite it in a slightly nicer way. I'm just going to pull the negative 4 out to the beginning. And copy down the negative 5x to the 4th plus 1. Then I'm going to look at the second term. This is one big product. This times this times this. So if I pull this part and this part out to the beginning, and then I've got a negative here already. I have negative 40, another negative makes it positive 40x cubed. And I'm going to copy down the negative 4x plus 3 and the negative 5x to the 4th plus 1 all over the low squared, which again I'm just going to multiply these powers. So negative 5x to the 4th plus 1 to the 4th. Now in order to simplify this, once again I'm going to look for a common factor. So common factor here. These are both divisible by negative 4 because negative 4 and 40 have that in common. Also, this first term has 2 copies of this guy, and this second term has 1 copy, so I'm going to take out 1 copy of that guy. And then I'm going to write down what's left. So what's left would be 1 copy of the negative 5x to the 4th plus 1 minus, and I'm going to have 10x cubed times the negative 4x plus 3. Ooh, you can't really see what I'm writing. Okay, I'm going to pause for a second. You know what? I'm just going to write it on the next row to make it look better. Here we go. I don't want to squish it in. I don't want to confuse anyone. So I'm going to have negative 4 times the negative 5x to the 4th plus 1, which is by common factor. And what's left would be 1 copy of the negative 5x to the 4th plus 1, which was left over from the blue part, minus 10x cubed, because I divided by negative 4, and the negative 4x plus 3. I don't have this orange part left, the negative 5x to the 4th plus 1 anymore, because I took that out. All over the negative 5x to the fourth plus 1 to the fourth. Now I'm going to do a couple things at once here, so see if you can stay with me. This is one big product. It's this times all the purple stuff. So because it's a product, I can cancel. And I can cancel one copy of this with one copy on the bottom. Now I can also simplify. So if I do that, I'm going to have negative 4, which was still on the top, and then inside of the purple parentheses, negative 5x to the fourth. I'm going to distribute here mentally, and I get 40x to the fourth minus 30x to the third. Negative 5 plus 40 would be 35x to the fourth minus 30x to the third. And then don't forget about this plus 1. All over, now remember we canceled one copy on the bottom. So we have negative 5x to the fourth plus 1 to the third power. There we go. Rather than trying to squish it in over here, just show all of that work. Okay. So we've gotten progressively more challenging. We started with a pretty basic chain rule problem, then we did a product rule with a chain rule, then we did a quotient rule with a chain rule. Next, we're going to look at a problem that has a root in it, basically. So we're going to do a product rule with a root, and then we will do a quotient rule with a root. And then the last thing we will do is the problem 14, which had a fractional exponent and a quotient rule, which was a little bit tricky, I think. Maybe. So, this problem, the original problem from class was problem 7, and the problem was y equals 3x to the third plus 4, and then the fourth root of negative 3x minus 1. Again, right away here, I'm noticing that I need product rule. I also notice that as part of product rule, because there's a root with stuff inside, I'm going to need chain rule there. So let's try it. Product rule says copy the first guy, take the derivative of the second guy. For me, taking the derivative of this part becomes easier when I think about this as being to the 1/4 power. So again, I just copied this part. I'm trying to take the derivative of this part, which I think is easier if you think about it as a fraction. So to get that derivative, I would drop the 1/4 and make it a negative 3/4 power by subtracting 1, and I would leave the inside alone. Then I would need to multiply by the derivative of the inside, which would be negative 3. This is all part of doing the derivative of this part. Now, product rule says that you copy the first one, you do the derivative of the second one, and then you copy the second one. And I'm not doing the derivative this time, so the root doesn't really bother me here. And then I do the derivative of the first one, which would be 9x squared. Now from here, it's just, again, simplifying. So in order to simplify this, I'm going to take this negative exponent, and I'm going to try to make this, clean up this first term a little bit. So stuff that's going to stay on the top. This guy, the 1, which is already on the top, and the negative 3. Which means the numerator is going to look like this. Negative 3 times 3x to the third plus 4. And the denominator, I'll do this one. The denominator will be the 4 and this stuff, which has a negative power. I'm going to rewrite this as the fourth root again of negative 3x minus 1 to the third, because to the 3/4 means fourth root to the third. Now I'm going to see if I can clean up the second term at all. And all I'm going to do here is I'm going to move this to the beginning. So I'm going to have a plus sign, 9x squared, and then the fourth root of this thing. Okay. Now in order to add these, I'm going to need a common denominator. This term is really over 1. To make this denominator and this denominator the same, I'm going to need to multiply by 4 times the 4th root of negative 3x minus 1 to the 3rd power on both the top and the bottom. Again, I'm making a common denominator. Now, the first fraction already had the denominator that we wanted. So when I combine these, the denominator for both of them is going to be this thing. The whole idea here is that when I combine them, this all becomes one big fraction with this denominator. Since the first fraction already had that denominator, I just leave what was in the numerator alone, and I put it in the numerator of the new fraction. Now what's going to change here is what's in the second part of this fraction. 9 times 4 would be 36x squared. And then I have a 4th root of this stuff times a 4th root of this stuff cubed. The invisible power here is a 1. Since 1 plus 3 would equal 4, and I'm taking the 4th root of this thing to the 4th power because I would add the powers. 1 plus 3 is 4, so I have a 4th power and a 4th root. The 4th root and the 4th power cancel. So all I have left is negative 3x minus 1. Now I'm just going to distribute and combine like terms. So when I distribute the negative 3 and when I distribute the 36x squared, I get negative 9x cubed minus 12 minus 36 times 3, carry the 1 is 9 is 10, x cubed minus 36x squared. Sorry, I was just doing some arithmetic in my head there. Now I can see that there are some like terms. So negative 108 and negative 9 would be negative 117x cubed. And I'm going to copy down the negative 36x squared and the negative 12 and leave the 4th root of negative 3x minus 1 cubed in the denominator. Okay. The next one we're going to do is problem number 10 from in class today, and then we will do one more and we're done. So problem number 10 from in class today was y equals the square root of parentheses negative 2x minus 5 divided by negative x to the 4th minus 5. Personally, I find it easier to do this problem if I think about this as negative 2x minus 5 over negative x to the 4th minus 5 to the 1/2 power. And if I take the derivative here, I can see right away I'm going to have to use chain rule first, and then I'm going to have to use quotient rule second, because I'm going to need to do the derivative of the outside first, and then to get the derivative of what's inside there, I'm going to have to incorporate quotient rule. So let's start with the chain rule part. I'm going to drop the 1/2, leave the inside alone, and make it a negative 1/2 power. Then I'm going to take the derivative of the inside. So if I look at just the inside here, I'm going to need quotient rule. So low d high minus high d low and low squared goes down below. Okay, now it's just a simplifying game. The first thing I know is that this negative 1/2 would really get distributed to the top and the bottom, which means both the top and the bottom have a negative exponent. Now here are the rules about negative exponents. If your exponent is negative and it's on the top, it moves that to the bottom. If your exponent is negative and it's on the bottom, it moves that to the top. So my new fraction would look like this. The 1 and the 2 stay in the same spot. The bottom would go up and become a square root. And the top would go down and become a square root. And then I'm just going to simplify this. I'm going to distribute the negative 2. So I get positive 2x to the 4th plus 10. I'm going to distribute the negative 4x cubed and the negative at the same time. So negative 2 and negative 4 makes positive 8, but when I distribute the negative, it makes negative 8x to the 4th. Negative 4 and negative 5 makes positive 20, but when I make it a negative again, it's a negative 20x cubed. All over negative x to the 4th minus 5 squared. Now I'm going to simplify. So in the numerator here, I've got this guy and I've got this guy that can be combined, which means this green part doesn't change. I'm not going to write the 1 because I don't feel that it's really necessary. And then I'm going to have negative 6x to the 4th minus 20x cubed plus 10 all over this guy squared. Now, we have rules about multiplying fractions. Oh, you can't see anything I just wrote down. Let me just take a second and let you copy that down. Now, we have certain rules about multiplying fractions that we have to follow. The rule is if you're multiplying, you just go straight across the top and straight across the bottom. So as a result, this just becomes one big fraction because we're multiplying. Now we can look for things that might simplify. One of the things that I notice is that this inside stuff is the same as this inside stuff. And a square root is really a 1/2 power. When I have a division problem, see how this one's on the top and this one's on the bottom, and I've got powers, I just subtract the exponents. So when I subtract, 2 minus 1/2 becomes 3/2. And because the 2 is the bigger number and it's on the bottom, I'm going to put this parentheses on the bottom. Nothing else here is really changing. I'm just going to copy the negative 6x to the 4th minus 20x cubed plus 10. And I'm going to put down here the 2 at the beginning and the square root of negative 2x minus 5. And then I notice that all of these coefficients, this is one big product, so this has a factor of 2, and all of these numbers have a factor of 2. So if I reduce this and I divide them all by 2, I get negative 3x to the 4th minus 10x cubed plus 5 divided by negative x to the 4th minus 5 to the 3/2 and the square root of negative 2x minus 5. And I'm done. Okay. Now, for the whole big hard one that I know a lot of students had trouble with, we're going to talk about number 14. So number 14 from in class today. The original problem was y equals 5x squared plus 4 over negative 3x to the 5th plus 1, all to the 1/5 power. Right away upon looking at this, I can tell I'm going to need chain rule because I have a fractional exponent outside of a big parentheses, and then to do the derivative of the inside, I'm going to need quotient rule. So let's do it. I'm going to start by dropping the 1/5 power. So 1/5, I'm going to leave the inside alone, and I'm going to make this a negative 4/5 power. And the inside is just going to stay 5x squared plus 4 over negative 3x to the 5th plus 1. And now I need to do the derivative of the inside. So, quotient rule. Low d high, which is 10x, minus high, 5x squared minus 4, d low, negative 15x to the 4th, and low squared, negative 3x to the 5th plus 1, goes down below. Now it's just a simplifying game. So I'm going to, once again, same thing I did with the 1/2 in the other problem. I know that this applies to both the top and the bottom, and I know that a negative power means that they're going to switch. The bottom's going to move to the top, and the top's going to move to the bottom. So I'm going to leave the 1 on the top and the 5 on the bottom, and I'm going to make this a 4/5 power, which is a 5th root of something to the 4th. The bottom is going to go on the top, and the top is going to go on the bottom. I'm going to simplify what's inside this parentheses, well, this big bracket. I'm going to distribute the 10x. I'm going to distribute the negative 15x to the 4th and the negative. So I get negative 30x to the 6th plus 10x plus 75x to the 6th minus 60x to the 4th, all over this thing squared. Okay, now I'm going to try to simplify. So I see some like terms, negative 30x to the 6th, 75x to the 6th, which means I'm going to have this whole thing is going to stay the same, except for I'm not going to write the 1. And then this is going to become 45x to the 6th minus 60x to the 4th plus 10x all over negative 3x to the 5th plus 1 squared. Last but not least, I'm going to do the same thing I did in the previous problem. If you'll notice, the inside of this is the same as the inside of this. Now this is really a 4/5 power. So if I take this power, the 2, minus the 4/5, I get 6/5. And it's going to go back on the bottom because the 2 is the bigger number. So I'm going to have the 5th root of negative 3x to the 5th plus 1 to the 6th, because it's the 6/5 power. I'm going to have the 5 and the 5th root of 5x squared minus 4 to the 4th power, because that was already on the bottom. And the top is going to be 45x to the 6th minus 60x to the 4th plus 10x. Last but not least, I noticed that there's a 5 here as part of this product, and that all of these numbers are divisible by 5. So my last step is just to simplify those numbers. 45 divided by 5 would be 9x to the 6th minus 12x to the 4th plus 2x all over the 5th root of negative 3x to the 5th. Ooh, I didn't write the 1 over here. I'm sorry. Plus 1 to the 6th times the 5th root of 5x squared minus 4 to the 4th. And that's your final answer. I hope this helped a little bit. I know some of us were a little bit overwhelmed today in class have some confidence that you were getting stuck on some of the algebra, hopefully, and that the calculus part was really okay. And we can work on the algebra part. We will work on the algebra part a lot of times. So I will see you guys tomorrow. We're going to practice more sort of chain rule problems and stuff like that. And yeah, have a great night.